For those who are not driving, or if you're not, lifting heavy machinery, at this point, I do ask that you take some notes, as these are valuable insights already. As he was talking, I already had questions around town planning. When he mentioned town planning, I remember growing up in Nigeria. Forget the British accent. I was born in Ogun State in Ijebu. I only have this accent because I don't want them to collect their passport from me. So that's why I have this accent. But I remember growing up in Nigeria, and town planning was a big thing, where everyone talked about town planning. So I really wanted to ask him about town planning as he talked about that. But that's really great. Engineer Wale, do we have you back? Please let me know if you're back, because there are quite a number of people on here, so I don't know if you're back yet. Okay, I don't think he's back yet. Just for your information, we also have this currently being live streamed on our social media platforms, on YouTube channel, on the YouTube First View YouTube channel. It's currently ongoing live streaming. It's live streaming on Facebook as well, and people are joining from all parts of the world, listening to the valuable insights that we're sharing today. So while we wait for Mr. Wale, we'll probably have him back to conclude his presentation. I will go to our next speaker, Engineer Gabriel Banjo Kaude Ige. Engineer Kaude Ige obtained a BSc degree in Civil and Structural Engineering from the University of Bradford in 1985. He subsequently obtained a postgraduate diploma in Property Valuation and Law at City University of London in 1995. He's a member of the Chartered Institute of Builders UK and a member of the Nigerian Society of Engineers. Mr. Kaude has worked on the construction of at least 12 successful medium to high-rise buildings during his career as site engineer, agent, project manager, senior construction manager, and now regional planning manager with Vinci Construction UK. He has also worked on a number of complex buildings and civil engineering projects, including roads, motorways, bridges, dams, harbor, yacht marina, tunnels, hospitals, schools, residential and office buildings in the UK, Gibraltar and Jersey Channel Islands. He has done some consultancy work in Nigeria, Ghana, South Africa, and Gambia. And I'm hoping that he can make me his personal assistant so that I can follow him all around the world where he's doing this great work. I had a peep at his presentation. I saw some really fantastic case studies that he's going to be sharing with us. Ladies and gentlemen, please help me welcome Mr. Gabriel Ige as he gives this presentation. Mr. Ige, I believe you're on mute, sir.
Yeah, thank you so much, Sean.
Yes,
can you see my screen? Yes, you can. Okay. Thank you all for spending this Saturday morning with us. I'm just trying to get my slide. Right. Am I on slideshow format now, Sean? Yeah. Hello, Sean, am I on slideshow? Can you see my slide? Hello?
Yes, we can. Yes, we can.
Oh, you can.
Sorry, you can't see me. I was giving you thumbs up, but you can't see me.
Okay. Okay. Thank you so much. I'm delighted to be here today to share my experience. I mean, most of my experience has been from the UK, but I've had some short-term. I've done some short-term consultancy work in Nigeria and interacted with various stakeholders in the construction industry. Yeah, this slide is just showing a few of notable projects I've worked on. The first one on the top left is a job we're currently building, and that photograph there is it's not an artist's impression. That's actually a photograph of the project taken from another project which is 38 stories. This project is for the is the secondary campus for University College London, and it's based at the Stratford Olympic Village. Students accommodation, 524 rooms, 2 towers, one 19-story and another 16-story, sitting above 4 floors of academic space. That's the value of that is 100 million, and it's due to be completed in May next year. So we're working really hard to get that done. The second one from the left is a project called Altitude 25. This was built in Croydon, 2009. I was planning manager for that, right from inception to completion. 35 million pounds. The third from the left is a Sikh temple in Southall, and that's probably the most complex structure I've ever worked on. As you can see, it's a dining room where 2,000 people sit on the floor and have meals. So you can see there's no columns within 22 meters. So there's a 22-meter span first floor slab, which is quite amazing to achieve. That was also successfully completed. The fourth is 29 Park Street, which is 8 stories in London Bridge. There's 6 floors of office space and penthouses at the top. So just move on to the next slide. Next slide just covers what my presentation is going to be about. Introduction, the project team and stakeholders, project program, permanent design, temporary works design, approvals, CDM and health and safety, quality control and project management tools. Right. So this is a brief introduction. High-rise buildings, well, in the UK are buildings which are 13 floors and above. Every country has their own definition of high-rise buildings. So this is not a contradiction of what this first speaker has spoken about. So construction of high-rise building is a complex process which involves the following key stages. I mean, some of them overlap and some of them might be interchangeable, but generally, this is just some high-level steps. Project initiation, outline design, evaluation, approvals, tendering, procurement, mobilization, construction, final mechanical and electrical commissioning, soft landing, and handover. As I said, some of these activities will overlap. In addition to the project team, stakeholders like the local council, planning and building authorities, neighbors, end users, safety authorities, fire brigade will be involved and have to they have to provide approvals and consent on various stages of the project. To successfully deliver the construction of a high-rise building, the project team should have suitably qualified key staff with relevant experience and skills and a track record of successfully delivering similar projects in the past. That is absolute key. Okay, move on to the next slide. So project team and stakeholders. In the UK, for projects like a high rise, when you're talking about, 50 to 100 million pounds, the client would actually appoint a client's project manager. The client's project manager will be a company that specializes in overseeing the whole project, because the client doesn't necessarily have that expertise unless he has an in-house team to manage that project. So vital that you appoint a suitably qualified, experienced client's project manager, which is not just one individual, it's actually a company like Turner and Townsend, who are international client project manager. So the client's project manager will have a project manager or project director. He will have a project quantity surveyor who looks after the financials, and then it will also have a technical advisor who would review and approve the architect's design, structural engineer's design, the MEP. So he'll be a multidisciplinary technical advisor. Those are the first few steps that are vital in starting this process off. You'd also have stakeholders and government agencies. Stakeholders are the end users. They get involved in and review the initial designs. Town planning authorities, building control, fire brigade. The next is the design team. So the client's project manager will appoint design team after interviewing them, obviously checking on their relevant experience, which similar projects have they done in the last 5 years successfully. They'll get references as well. And then you have the main contractors teams. So you have architect, structural engineer, I know the fire consultant, landscape acoustic consultant. Then you have the main contractors team. You'd have, for a project like this, you have a project director, regional planning manager, which is my role, senior commercial manager, M&E services manager, temporary works design engineer, senior project manager. Then you have a few project managers, senior design managers, construction managers, quantity surveyors, site engineers, logistics manager, document controller. I mean, you could have up to 30 or more staff, secretary, delivery, notes manager, and then trainee apprentices, because how do you get the experience? On our job, this current job, UCL, we have 3 trainee apprentices, and we train them. They shadow senior construction managers, and that's the way you transfer the knowledge. You have to have these apprentices, and it's not just about academics alone. So what they're doing is they're doing day release. They're going to university. Well, they started with OND and they end up university, but they're doing it part-time. So they're working 3 to 4 days a week and doing 1 day university. So they're getting both sides. Then you also have part of the team who are quite vital as well, are the subcontractors. And I've just listed the sort of the packages, the works packages, site setup. When you start on a job, you have to set up site accommodation, the cabins, toilets, and stuff like that. Then enabling works, you have to do surveys of the existing ground. There might be services, electric cables, tunnels, God knows what. You have to make sure all those are diverted before you start building your foundation. Then the substructure, superstructure, roofing. On this project, we have like about 60 subcontractors, and we oversee and coordinate them. Right, one vital tool that we use is, and I'm the one that manages, is a program, and we use a software to produce Gantt charts, and that covers. So at tender stage, you would have mainly the program is broken into 3 stages. Pre-construction covers what the previous speakers talked about, which is generally client's brief. Then you appoint the client's project manager, appoint the design team. Then you do outline design. At that, then you engage some specialist subcontractors because they do it all the time, like cladding, concrete frame. There's some companies that's all they do, so they're masters at it. So you engage them at an early stage. They will tell you the most cost-effective way to do it and techniques. Then you have cost planning. Your quantity surveyors, they need to be, as design is progressing, you need to be developing cost plans, just checking the cost, that cost is staying within the client's budget. Then you do concept design, town planning, scheme design, pre-qualified contractors, contractors tender. Then you appoint the main contractor, and then usually we do a lot of design and build in the UK. So he now takes over the design and does the coordinated and construction issue information. Then mobilization, vital that you have at least 4 weeks mobilization. I know in Nigeria, sometimes they say they appoint you and they say start on site tomorrow. It doesn't work. And then the construction phase follows from there. These are the stages of permanent design, because you have permanent design and temporary design. It's all self-explanatory. Temporary works design. Temporary works, the design solution is used to support the permanent work. So while the concrete is still not up to strength, you need to put in some temporary works to temporary support till the concrete slab and beams gains 28-day strength. Or we use it to support trenches while we're excavating for drainage, or temporary works is the foundation for tower crane, and also sometimes access scaffold for access. And you can put in some fans as well to protect people walking below, including the public. So example of temporary works is site boundary holding, site accommodation gantry, tower crane foundation, canty deck, hoist, mast climbers, and so forth. You can see there's some sketches here, which shows the one on the left, where you have a suspended slab as you're going up till the slab gains 20-day threads. You have to actually put in some props. So you have the false walk right at the top, which supports the slab that you're going to cast. And then below that, you need to have another 2 levels of props, just to make sure that, because the slabs below might not be able to take all that load, because the loads haven't been transferred into the column. So you temporarily do that, and you crush your cubes till the slab above reaches the required strength. Then you can remove some of the props. Approvals. Consulting engineer, he does the design, and then another in-house engineer will do an independent check on his design. Then you submit to building control. He does the checks and approves before we start on site. The client's technical advisor would also do his own checks and approve. There are also some subcontractor design elements, like, structural steel or cladding, which has to be, the subcontractor would develop the design and then submit for approval again to the structural engineer. So at every stage, everything must be checked and approved before you actually go into manufacturing. CDM regulation, construction design management regulations. It's a law, an act in the UK where everybody has responsibility, every player. And the aim of CDM regulations is to improve health and safety in construction work. Excuse me. It's a legal requirement. The golden rules of CDM. CDM applies to every construction work in the UK. Even if it's 1 hour work, you must apply CDM. Anyone appointed to work on a construction project must have the skills, knowledge, and experience to carry out their role. Each duty holder has his own duties that he must carry out under CDM. The role of the principal designer and the principal contractor must be appointed on a project with more than one contractor. There can only be one principal designer, and that principal designer is responsible for the design. Principal contractor is responsible for safety on the construction site. Projects with more than 500 people days or 30 working days and more than 20 workers need to be notified to the health and safety executive. Pre-construction information must be provided by the client on every project. A construction phase plan must be provided for every project by the principal contractor or sole contractor. The principal designer must create and develop a health and safety plan to hand over on completion of the project. The client, there's one bullet point I missed, that the client also has responsibilities under CDM. So everybody has responsibilities. Nobody can say, I blame you for that. You have your own responsibility legally. Quality control. There's some basic but very important quality control procedures. Before you even start constructing, you need to produce what we call inspection and test plans. You produce that by going through the structural engineer's specification and list out anything that needs to be approved. For example, the pole layout of the plan, where your construction joints are going to be. It'll tell you how many cubes you're supposed to test, slump, and it will tell you the layout of your formwork. And it just, it's like a checklist that you give to the engineer, and he can use that for his checks. So basic checks before the concrete is cast is check the formwork, check the false work. False work is what supports the formwork, which is the plywood that contains the concrete. Check the reinforcement, that is according to the to the reinforcement drawing. Check cover, that is the gap between the reinforcement and the formwork, that so the concrete is surrounded properly in concrete and it performs as required. Check for cleanliness. If you have mud in the concrete, it wouldn't perform as it's supposed to be. Once you've done all your checks, the site engineer would sign an inspection sheet showing exactly what checks is done, what remedial works has been done before the concrete is gone. When the concrete arrives, you check the delivery note. We have ready mix concrete in the UK. Make sure it's the right concrete mix, because in some cases the wrong concrete mix has been delivered, and if you don't catch it in time, then you're looking for trouble. Before the concrete goes in, you do a slump test that sort of checks on the workability. Make sure there's not too much water. You can see an example at the top, the photograph for what looks like well, if you're casting a slab, it looks like the slump is usually between 50 and 75 millimeter. That looks like a good slump. And then the second slide, you can see the concrete's collapsed. That looks like for reinforced concrete, that looks like concrete for piles, but not for a slab. And then we take cubes every, can't remember, maybe it's every 14 meters or every 20 meters of concrete. You cast cubes, which will be tested at 7 days. If it doesn't reach the predicted 7-day test, then you know there's something wrong. So you test more cubes. If that fails, then you test the actual slab. If that fails, then that means the slab is not sound. You probably have to take it out. So these are checks and balances that will prevent disaster. And then concrete pour records. Every time you pour concrete, you mark on a drawing exactly which pour was done which day, so that if there's a problem, you can isolate that area. And then you also plot the graphs of your concrete cube tests, so you can see the trends. And if one area, you can see one area is lower than the rest of it, then you know there's a problem. Move on to the next slide. Project management tools. This is some of the tools that we use. Planning software, Gantt chart for planning and monitoring time. Contract program, town planning conditions tracker, because we have, when you get planning consent, there are conditions you have to meet before you start on site, and there are also conditions you have to meet while you're constructing, and also some preoccupation. So you need to make sure, and there could be hundreds, so you need to have a tracker, monitor them. We have a risk register where you identify risks and agree on mitigation to minimize the risks. Information required schedule. This schedule we give to the design team just to tell them when we need their design. Request for information. That is when there's a query on the drawing or something not right. We have a schedule for sending that to the design team. Inspection and test plan, I've talked about. Design program, procurement program. Every month we submit the client's progress report before we meet the client. We have a meeting with the client every month. Target program, logistics plan. A logistics plan will cover the movement of materials and plant. So there's vertical. We use tower cranes for vertical lifting of materials, and also the hoist for moving materials and men up and down the building. Then we have what you call a Snagart. It's an iPad that you use for taking photographs and also recording any defective work. So this is the last page. Tips. I hope I haven't overrun my time. Tips for successfully delivering. Tips for successful project delivery. Appoint a suitably qualified and experienced client's project manager. Appoint suitably qualified and experienced main contractor. Appoint suitably qualified specialist key subcontractor like a concrete frame contractor, groundworks contractor, piling contractor, mechanical and electrical contractor, cladding contractor. Those are the real key ones. There's some other important ones, but these are the key ones. And then plan. Check. Monitor. Approval of every stage of the design and construction is vital, and in particular, the substructure and the superstructure frame. Establish robust quality control procedures and processes. The structure of a building is like the skeleton of a human being. You cannot compromise it. Get it right first time. It will be safer and more cost effective. Safety comes first. That's it. Thank you for your time. God bless.
Thank you very much, Engineer Ige. That was really profound in terms of how technical you went and the detail. Thank you very much. I do have a question about regulation. You hammered quite a lot about regulations, and I did different standpoints where regulation checks are being handled. My question is, in a country like Nigeria, where we've had some clients have had bad running with regulators, and almost the perception of regulators is that they're there to hamper your work. And I'm sure that's different from the UK. Most of your team will probably see regulators as propellers, as opposed to people who are there to stop your work. How do you advise the relationship? How should people have a relationship with regulators? What's the best way to view regulations as a client?
Well, as a client, I think in Nigeria, well, Tommy would expand more because he's an expert with building control. But for my experience, I don't believe in the UK we have building regulations, which is a legal requirement. You have to follow certain processes, certain steps. Otherwise, they will stop you and they could demolish your building. Then you also have the British standards, which is not a legal requirement, but it's a guidance, but it's tied into the building regulations. So I think but in Nigeria, I don't believe we have, I think we have the building code and stuff like that, but I don't think anything is legal, first of all. So enforcement sometimes can be difficult. The other thing is, I think it's to do with educating the populace. We need to be running, especially some of our bodies like the Nigerian Society of Engineers, the Architects Institute. We need to be running workshops and town hall seminars to educate the public, educate some of these clients. A lot of them don't realize the implications of what they're doing. You know, when they go and bribe some of these authorities, and at the end of the day, they don't realize that they're going to be the biggest losers. For example, this building that's collapsed, I think it's opened a lot of people's eyes. But the government itself government and our professional institutions, we need to work together to educate the public. Like, look, if you cut any corners, you're going to pay the price. It's very tough in Nigeria, but that's my suggestion. It's education. Once people understand the implications, then they'll think twice before they do what they're doing.
Awesome. Thank you very much. I apologize. I did say that the questions would be left to the last minute, but that was that regulation bit that you touched on just prompted me. So I'll leave the rest of the questions till the end. So that blame me for being overly enthusiastic. Can you please stop sharing your screen as I invite Engineer Wale back to conclude his presentation before he got disconnected. Engineer Wale, please, can you confirm that you can hear me?
I can hear you, thank you. I don't know where I stopped.
I believe you're on slide 5 at the time.
Thank you. I do apologize for that, distinguished ladies and gentlemen. I do apologize for that break in transmission. I was on slide 5, and slide 5 has to do with introduction. And I was mentioning that the design of a single-story building, a multi-story building, and a high-rise or skyscraper follows the same principle. And that is to transfer the load from the superstructure to the foundation. All vertical loads, all horizontal loads in the structure to transfer it to the foundation, and the foundation to be built without any unnecessary stress. Is 7 basic steps to property development. process. And the step one is the pre-purchase stage, whereby you go ahead and source for funds, source for the land, and decide on what to do. The second step is the contract negotiation. You negotiate for the price of the land and you buy it, or you might decide you want to take it on a lease and the terms of the lease. Then 3 is the town planning and development approval process. Usually in the UK, you might have to go to the council, first of all, obtain approval for the proposed development before you go and do the drawings and all those things. Here in Nigeria, it may not be necessary. So the next thing is you do your working drawings, and then after you do your working drawings, which is step 4, you go and submit to approval for to take approval. And then the step 5 is the construction, in which case you negotiate with the builders, you select a contractor, and then you hand over the site to him in step 6 for the construction. You hand over the site to the contractor, and he does all his work under supervision. And when he completes his work, step 7 is the completion. He hands over the keys to you. And then you decide whether you want to sell or you want to lease the building, you want to make quick money, or you want to make longer time. The professionals involved in the design of a high-rise structure is the same you will need when you want to design a bungalow. And this includes the land surveyor, the architect, the structural engineer, the geotechnical engineer, the quantity surveyor, the service engineers, and then the contractor. We encourage people to engage only competent and capable registered professionals on your project. And the client has the right to view your qualifications to confirm that you are not a quack. Step by step of design process for the building development. The first is the architect's brief. When the client or the developer goes to the architect, he enlists an architect and gives him the brief, what he wants to do. The next, architect draws the drawings, and then he hands over the drawings to the structural engineer. The client engages the structural engineer, enlists him, and the structural engineer does his drawings. In order to complete his job, the structural engineer needs the soil test report. You must do soil test report for every site you are building on. And under every building, you must do a soil test. And then the geotechnical engineer writes the report and sends it to you. You are interested as an engineer in the soil profile under the building and on the allowable bearing capacity of the soil. After the structural engineer completes his job, he gives the drawings to the client. The client also enlists services engineer, M&E, and the rest, and all of them do their calculations and drawings and hands them over to the client. The client then enlists a quantity surveyor who does the bill of quantities, and then they can invite bids. The bid can be open or closed. Open, you advertise to the general public and they submit. Closed one, you select some contractors and then they make their bids. And then you select the best 3 and then you invite them for further negotiations. After that, once everything is done, they move to site and they start the work. It is best to verify professionals and then make sure that you also have a agreement for residency supervision. Construction cannot start until approval is given. Select your builders. Then consultants are required from the start of the construction to the end of the construction work. You jeopardize your investment and property when you refuse to engage professionals in site supervision. Basic design steps. For the structural engineer, the first thing is to do your structural layout. That is the general arrangement of the floor plan. You arrange the slab to be supported on the beams. You arrange the beams to be supported on the columns. And the columns, you try as much as possible for them to be vertical and to transmit the load directly from the upper floors to the foundation. When your columns are not straight, you have more headaches. This is a basic typical floor plan, and you can see a typical frame structure. You can see the columns, they are straight and they go down. Most of the time when you are doing your design, you start from the roof and then you go down. I, as a person, I make sure that I arrange my frames in grids. And each column, I can identify them from the grids. I can call them column B12. That is the column on grid line B, and on the other side on 12. Basic design steps, like I said, you design your calculations and you do everything from slab onto beam onto column and floor by floor. For high-rise buildings, you need to check the stability of the structure under wind load. You need to obtain the wind load and distribute it onto the wind-resisting elements. Usually, we use shear walls. But if you don't want to use the shear wall, you can use column and a frame structure. Then you also check that the shear walls, there is no uplift. And if there is uplift, then you find a way to anchor it onto the supporting pile foundation. So these are the principal structural elements that you design. And then basic signs of distress in a building, you have cracks, horizontal or vertical. When you have vertical, it's a sign of foundation problem. Then you can also have settlement, and you can also have tilting. Tilting is a form of settlement, but differential settlement. And you can have settlement, everything settles down along the same direction. But once you have a settlement of more than 25 mm, then you may be having a foundation problem. Foundation. For every foundation, like I said, you need a soil test report, and the soil test report must be done by a registered professional. There are many quirks in the system, and this is why I'm mentioning all this. When the time comes to share some experiences, we can talk further on that. Reasons for building collapses in Nigeria. The first one I would say is faulty structural designs. Use of unqualified personnel, inadequate supervision, sharp practices, and then I will also say influence of foreign professionals. When we need to expand on that, I will do that. Investigation of the 21-story building collapse. What I would do as an investigator, I will investigate the substructure. The first thing I need is the soil test report. The next thing is I need a pile load test. I need a pile integrity test. I also need to check the bearing capacity and the terminal depth of the piles. These are areas where you have sharp practices. You have somebody, you say, do a piling to 30 meters. He stops the piling at 12 meters. One, you have reduced the pile capacity. Two, if you are unlucky and you have a deep depth of pits, then you will be putting your building on inadequate soil. The superstructure, I will check the columns, I will check all the structural, I will obtain the structural drawings, I will obtain the structural calculations, and I will check every structural element, especially the columns. The collapse is a total collapse. It is not partial, and that is what makes it more serious and a very serious impact. Engage only recommendations, engage only competent and capable registered professionals. Teach developers basic elements of structural design. Every high-rise structure must have experienced resident supervising structural engineer. Every high-rise structure must be built by a certified registered contractor. Use of direct labor method of construction for high-rise buildings must be banned. Every building is a responsibility of the Nigerian engineer, because when a building collapses, it is a reflection of the Nigerian engineer. So as we go along in our daily path, look at structures. And if you see anyone that may have a problem, call the government agency. So the building contractor must always have qualified engineers on site. For the geotechnical soil test report, like I said, because everything you are building depends on the ability of the soil to sustain those imposed loads, the soil test report must be done by a registered professional. And you must check that you are not using a quack. On the pipe foundations, the same thing. We have piling contractors now who are not really engineers. Some may have worked under some engineers before, and then all they do is get money, buy rig, and then they say they are piling contractors, and they go ahead and start piling. Meanwhile, they are not adequately equipped, either in terms of academics or knowledge. Material testing. Institution-based material testing laboratories like University of Lagos, Yaba College of Technology should be used in advisory capacity and to assist in material testing. As far back as 1990, as the staff of Overop and Partners, all our tests, all our contractors are referred to University of Lagos for material testing. And I can say there was little or no building collapses then. Say no to vertical extension. Once a foundation has been built and you now go and raise the structure, you are adding load, which has not been accounted for in the foundation design. I can share one or two experiences later, but if you know you want to go for 20 floors, you can design your structure for 20 floors and the foundation for 20 floors, and then build it to 10 floors if you don't have money. And then you continue later when you have money. So right from the beginning, design your building and the foundation to carry the number of floors you want it to be done. For the 21-story building, there are some other recommendations that you need to do. But because of time, let me just run to my conclusions. Engage only competent and capable registered professionals on your project. Clients can request a copy of the professional's documents. And if the name on that document is not the person you have been talking to, just know straight that is a quack. Consultants are required from the start of a project to the end of the project. You jeopardize your investment and property when you refuse to engage professionals in supervision. Every building is a responsibility of the Nigerian engineer. Institutional-based material testing laboratories are highly recommended. Say no to vertical extension. Thank you. Have a nice day, sir.
Thank you very much, Engineer Ogundalu. Thank you for that really powerful and insight that you've shared. Without further ado, I do look forward to the questions. I have some questions written down, but we'll come back to that towards the end. But I want to bring up the next speaker. The next speaker is Mrs. Udo Okonjo. Mrs. Udo Okonjo is an international lawyer and astute real estate entrepreneur who is currently the Chief Executive Officer and Vice Chairman of Fine and Country West Africa. She also serves as an independent director and chair of the Governance and Remuneration Committee on the board of CAP PLC, a subsidiary of UACN PLC, one of Nigeria's oldest and largest publicly listed conglomerates. Mrs. Okonjo is a seasoned legal practitioner who was admitted to the Nigerian Bar Association and New York Bar in 1991 and 1994, respectively. She has had a successful legal and entrepreneurial career for more than 3 decades. Udo acted as the senior special advisor on legal and constitutional matters to the Senate President of the Federal Republic of Nigeria and was a partner at a leading commercial law firm, Templars Barristers and Solicitors. As the best graduating female student at the Nigerian Law School in 1991, Mrs. Udo Okonjo was awarded the prestigious British Chevening Scholarship to study at the University of London, King's College School of Law, where she graduated with a master's degree in law, specializing in corporate and commercial law. She's also the founder and chief igniter of the Inspired Women of Worth Network, a business and lifestyle network for African female entrepreneurs and change makers. She's also the founding chair of IWOW, that's Inspired Women of Worth Leadership Academy, an institution established to transform society through empowered female leaders, along with Ignite Africa, an initiative to enrich, transform, and connect the next generation of African entrepreneurs through experiential learning. Notably, recently under her leadership, Fine and Country West Africa has launched a cutting-edge real estate leadership development program in collaboration with the Executive Management Division of the prestigious Lagos Business School. She believes in inspiring and empowering African entrepreneurs to think big and live their best lives while building purposeful, prominent, and profitable businesses. She believes that true African transformation will start with champions who take responsibility for changing their lives and others around them through right thinking and actions. Ladies and gentlemen, it gives me great pleasure to invite Mrs. Udo Okonjo.
Thank you very much, Seun. Ladies and gentlemen, I would like to say good morning and thank you to the organizers of this very important forum, the Nigerian British Infrastructure Group. Prince Afolabi, I say thank you for the privilege to be here. Thank you, Seun. I'm going to go right into my presentation over the next 15 minutes. My specific topic is on investing in luxury residential high-rise properties. What are the factors to consider? Before I go into the presentation, I'd like to share a quote by a woman I refer to as a power woman, Audrey Hepburn, in which she says, "I don't believe in collective guilt, but I do believe in collective responsibility." And I would like to echo those very thoughts, especially as we all in this particular forum have in mind the tragedy that happened a few weeks ago in Ikoyi, which is the main place where Fine and Country West Africa not only has its office, but also serves our clients all across Nigeria. With that in mind, I want to focus my presentation on the end user point of view. We are a real estate marketing firm. We're also an advisory firm, and we specialize in off-plan and new build developments, mainly in the luxury residential and in the prime commercial. As a result of that, pretty much 99.9% of all the projects that Fine and Country West Africa deals with and has dealt with in the last 12 years are what you may refer to as high-rise buildings in Nigeria, mainly in Ikoyi and in Abuja, Maitama, Sokoro, and similar locations. In real estate, it's said that location is one of the core maxims. However, we like to believe that astute investors need to go beyond location. And we will share why in the next couple of minutes. The above properties are a few samples of some high-rise projects in Nigeria. Specifically in Lagos, I would have liked to have included the World Trade Center in Abuja, which we worked on about a decade ago. But to your right and to my left, Nest Oil Towers, Grace, which is a mixed development project. The very next one is Greystone Tower, which is also a mixed development, both located in Victoria Island. The one next to it is Osborne Towers, which is in Ikoyi, that was completed many years ago, about 7 years ago, thereabouts. And then to my far right, and to your left is Eden Heights. I present a few of these properties representing some of the properties that Fine and Country West Africa has worked on and advised both developers and the buyers, investors, because the key factors that I will be sharing over the next few minutes will go back, to some of the ways in which we approach residential high-rise properties. Nest Oil, the main contractor there was Julius Berger. The next one, Greystone, was Dory. The next one was Capa Delbato. And the fourth one is ITB. I will come back to why I've mentioned that in a moment. We believe that astute investors must ask and understand the 5 W's of investing in specifically off-plan, high-rise luxury developments. It's not enough to look to invest in a property. The key thing in investing in new builds is that you are really trying to future-proof your investment. You are in a position where you are investing in a very high asset class with a lot of money, and therefore the investors in this category, and indeed in any level of real estate, must learn to ask the really tough questions. And those are the questions that I'd like to focus on. There are 5 key factors which we have presented as questions, and these questions form the core of the 20-something questions that we present in a questionnaire that we present to every real estate investor developer that approaches Fine and Country to bring their property to the market, because we believe that it is our responsibility to ensure that we advise the clients, i.e. the developers, and also protect the buyers, the end users who are either going to be living in these properties or who are investing in these properties for a return. They want to make sure that these properties are not only delivered in the short term, but that in the long term also these properties continue to give them considerable return. Therefore, we think from a point of view of future-proofing the project. The first question that we believe is important if you are looking to invest in a high-rise development, and indeed in any property, especially ones that haven't been built yet, is to ask the first question, who? This is a risk management question. It's important to profile, to understand who is building, who is the developer, who are the sponsors, who are the financiers, who are the key contractors. These are basic, they're foundational, they're fundamental, but it's incredible how many investors gloss over this very important question. It's important that buyers seek to understand the track record of completion of the project developers who are presenting and bringing properties into the market. The same applies to the contractor. Will the building be completed on time, to the stated quality? Do they have a track record of completing on time and delivering the quality? This really has to do with understanding who you're getting into bed with. In this particular case, who you are rising up into the skies with. As we see, it's a very critical question. It's also important to think in terms of the future management. Who will be managing this property? Because it's not enough to build a good quality property. It's important to ask, who is going to be managing it? How will it be managed? What are the rates?
Pause this. Pause it. Then both of you need to go look at it first.
Kindly, sorry about that, Mrs. Okonjo. Kindly mute yourself if you're not speaking. Thank you very much.
I'm going to just look back. Thank you, Sean. Just looking back to asking who, the who. High-rise developments lend themselves to being a very collaborative project, as all the speakers who've spoken, Engineer Ogundalu, Engineer Kayode Ige, who've spoken, many stakeholders. The government is a stakeholder, the regulators, the investors, the developers, the contractors, the consultants at the very early stage and throughout the lifetime of the project. I want to focus a bit on the financiers, and their role in these types of projects, because high-rise development, it's important to ask who is financing. This isn't child's game. It's not the type of property that anybody can come to the game with. If you're building 20 stories, 40 stories, 15 stories, 10 stories, I dare say, you want to find out how is it being funded. This is a critical risk area that many people don't avert their minds to. Obviously, we have a challenge around funding in Nigeria. And so some developers actually structure their projects in such a way as to attract funds from early stage buyers. And they're trying to use these payments to build these high-rise. Clearly, the risk is obvious, because of the types of payments that they need to commit to versus how these monies are coming into. Where we have seen significant challenges in terms of quality, in terms of even the types of professionals that are brought on board, it's usually when you have developers who do not have the right type of funding. And so the who is not just about the developer, it's what is the source of funding for this project. I will move on to the next one. The next question then becomes the what. What is being built? What type of development? Is it residential high-rise? Is it mixed development? Is it commercial? These questions relate to all these types of projects, but in particular, our focus is on residential. And then the key questions then becomes, what's your building approval? Do you have building approvals? Do you have permits? What is the zoning for this? It's incredible to see how many times, developers come to the table and say, oh, we're going to put up 15 stories or 18 stories or 25 stories. I remember many years ago, some developer came to our office at the time in Victoria Island. We are going to build the tallest building in Nigeria, in Lagos. It's going to be 25 or 30 stories. And these very simple questions, what is the zoning for that particular location? How many floors is allowed there? What is the density? I mean, these are, this information is available to all professionals. It's publicly available. And it's a basic question as far as we're concerned at Fine & Country West Africa. Unfortunately, I cannot tell you how many times we have interacted with developers who don't have the answer to this question or who don't have the correct answer. Some say, well, it's zoned for 10 floors, but we'll go for 18. We will do something about it. As Fine & Country, our response is, when you get the approvals, let us know. Of course, we also ask for the proof. It doesn't mean that people don't go ahead and do what they need to do, but I believe that these are the questions that must be asked. So as far as the what, you want to know what sort of zoning. I believe that it's important for investors to ask themselves if they are in bed, if they are rising high with the right foundation, if they are rising, because if the foundation is wrong, and by foundation here, I'm referring to the legal foundation, I'm referring to the statutory and to the regulatory foundation, because we imagine that in the future, this could even affect the quality of your title. If someone was meant to build only 40 apartments or 20 and they ended up with 60, one wonders what will happen in 10 years when, the Pharaoh that did not know you at the time comes into place. The third question is the when. Completion risk is critical for investors. If you're buying into a development as a buyer, as an investor, even as a funder, a financier, when will the development be completed? Is the time frame realistic? I can't tell you that we have met any developer that has presented their project within a realistic time frame. And so with experience now, anyone who tells us and gives us a time frame, we tend to, from a marketing point of view, encourage them to expand it. This is an important question because it has very important implications. High-rise buildings cost a lot of money, and the cost of delays are very significant. And this is what tends to lead to compromise along the way. Some people compromise in terms of finishing, in terms of quality. Hopefully they don't compromise at the early stages in terms of the structures, the foundation, and all the other critical elements. But from our point of view, as a marketing firm and as advisors, we tend to view the full 360-degree aspect of the project from the beginning to the end. We believe that if you have an extended, significantly extended timing, it could affect the quality of both the investment and the particular project because of compromises that may be made. And the fourth out of the 5 factors that we look at is the where. I did refer to the question of location being the first maxim in real estate. However, from our point of view, we believe that investors, buyers, and users should really begin to look at location from a more in-depth point of view. So just looking back to the project that collapsed a few weeks ago, and if most of us watched as they tried to go in and out of that particular location, while that location is within Ikoyi, you will believe that there are locations, micro locations, and locations within locations. You know, you have Southwest Ikoyi, you have Southeast Ikoyi, you have, you know, different, you know, mini locations within locations, and each one has its value depending on, you know, the infrastructure around the area, depending on how it's been zoned, and, you know, a few other features. But in particular with that particular project, if you notice the narrow access, and if you consider the number of properties and families and vehicular traffic that was going to happen, you know, in and out of there, then you begin to look in terms of location. Yes, it's in an upmarket location, Ikoyi, but in the real sense of the word, how would you view that location? So location is important. And obviously, as a developing economy, as Lagos, with the sort of population that it has, we're going to see more of high-rise buildings in the future, whether it's the Atlantic and in other locations, even the Marina, you know, where we're going to see regeneration and all of that. It's important that people begin to ask questions about the infrastructure to support the services and everything else, you know, environmental impact assessments and all of that. My final point, as far as the 5 W's that we look at as the key factors for investors to look at, is what we refer to as the wow factor, which I'm not going to spend too much time on. Suffice it to say that it's not enough to say that we want to rise sky high. We want to touch, you know, heaven or go wherever we want to go. The question is, what does it take to create those things? You know, when we look at Dubai, Singapore, and all of those locations in creating the wow factor, they definitely were using the top, you know, whether it's the professionals, the minds, and the specialists, and all of that. So the wow factor is always important when you talk about high-rise residential, but we should not compromise the wow factor, or we shouldn't, because we want to get the wow factor, you know, forget to actually do the work that it takes. I'm just going to wrap up in the next minute or two with our key recommendations. Regulation, we can't speak enough about it. It's not enough to have recommendations. It's important that we actually have regulations that are not just there, but actually enforced. It's important as we learn from the UK and other locations. Luckily, this forum is doing that because we're exchanging knowledge, that we begin to, as stakeholders, to go for more stringent requirements in the sector, because what affects one affects the others. We believe that regulators need to be more diligent. From our point of view, there's no way that the regulators can be absolved of responsibility and potentially liability in what has happened, but that's not our call to make. It will really come back to those who've invested and all the other stakeholders. Due diligence cannot be overemphasized. It's absolutely critical. The who, the what, the where, understanding in particular the who is building, and across the whole chain, the consultants and all of that. I dare say that when you're talking about high-rise buildings, you want to literally certify you know, contractors and consultants who have specialization in these types of things. I would like to wrap up on the legal considerations, because as we think about the tragedy that happened recently, unfortunately, it's coming across that, you know, this is a big gap, an area that, you know, people are going to struggle in terms of, we've seen buildings where people buy and they don't have receipts yet because their relationships or whatever. You know, the marketing firm, the sales professionals, the brokers, the developers, everyone is responsible for ensuring, as I said at the beginning, real estate investment is probably one of the most significant asset classes that people will invest in. And so it's absolutely critical that you have your ducks in a row as far as your documentation is concerned. Unfortunately, even some of the biggest developers tend to treat this with, kids' gloves, almost like we'll deal with it later. And so hopefully with what has happened, people begin to see that it's important to get this upfront. You get all your receipts, you get the title documents, you get contracts that specify exactly what you're getting, so that along the line, when they start, when, for example, a developer tries to change what was originally communicated, you have a contractual basis to actually address this. Insurance, obviously very critical. And as far as stakeholders and having data and, assessing consultants, contractors, and all the key contributors to a successful high-rise, we believe that it's important that there is a central repository that actually rates, in a sense. If you think about, five-star hotels, there's a rating system. If you think about Michelin star, not to talk about buildings where families, human beings, children, are going to be living in, surely there's a way for this to happen. It happens in other countries. We don't need to reinvent the wheel. We need to do what is right by society and for everyone. All members of the building sector must be vigilant and report projects that are not in compliance. And we have a responsibility to actually make sure that our reporting, especially for something that's significant, is taken on board. Once again, I would like to wrap up by saying I do not believe in collective guilt, but I do believe in collective responsibility. And I believe that that's what we're doing here today. On that note, I would like to say thank you very much to the organizers once again for this opportunity to share our perspective, and hopefully I can contribute further in the Q&A session. Thank you.
Thank you very much, Mrs. Udokonjo. You have done that topic great justice. Thank you for giving us the buyer's perspective and making sure that we as buyers are also part of those stakeholders and we have the right information. Thank you very much. I'm going to invite our next speaker, Engineer Olumide Odukale. Engineer Olumide Odukale is a seasoned architect with over 25 years practice experience from working as a young graduate architect and starting his own firm, Project Point Limited, in 2001, from where he has overseen a sizable body of work. Influences include contemporary art and design, music, African art and culture. Currently the principal architect and managing director of Project Point Limited, Lagos, Nigeria, and holds professional certifications and qualification. He is a principal architect for the development of 50-hectare Sapphire Garden Estate, Awoyaya Ibejuleki, Lagos, and was in charge of the overall layout of the estate, design of the residential and services buildings. He's also worked on a 7th-floor block of high luxury flats in Kofua Bayomi Street, VI, Lagos. He's worked on luxury and high-end residents in locations such as Banana Island, Osborne Foreshore Estates services, and he's rendered numerous services, including the selection and coordination of offshore components and procurement. He's been involved in the remodeling of offices for British American Tobacco at Victoria Island, Lagos. He's also worked on remodeling works of procurement department offices for Guinness PLC Ikeja. He's done remodeling of offices for FSDH Merchant Bank, Lagos. He has worked on several branch buildings for commercial banks from design to occupation. He holds a Master's of Science in Architecture, a Bachelor's of Science in Architecture, and he's also a member of Nigerian Institutes of Architects, as well as a member of Architects Registration Council of Nigeria. Ladies and gentlemen, I present to you Architect Olumide Odukale. Thank you very much, sir.
Thank you. Thank you very much, Sean. Good afternoon, everybody. Thank you for this opportunity to deliver this paper at this time in our country. My topic is globally accepted design and planning standards for high-rise and complex structures. So I want to start by, first of all, defining what do we mean by high-rise structure or complex structure. These are any man-made or engineered structures like taller than 75 feet or 25 meters, and they can be for various purposes, offices, commercial purposes. Some of them are, the telecommunication towers are also high-rise structures. Some were built out of pride and out of need or out of ego, just to prove a statement or to elevate the country that where it's placed. Some are monuments like the Eiffel Tower, the pyramids, and various other, Statue of Liberty, and various others. Now, what makes a structure or a building complex is the nature and relationship of the various elements and components that make the building functional or workable. These elements will arise from and include the design form or shape of the structure, the foundation on which it will sit, which is a challenge that we have seen today, especially in Lagos, where we have a lot of loose soil, the resistance to wind load and other lateral forces, the materials that are used, the efficiency of the building, mechanical and electrical services, and several other factors. Now, for the purposes of this presentation, I'll be discussing high-rise structures used as buildings. So specifically, I'll be talking about buildings. As we have said, and a few other speakers have said, I mean, a high-rise building is one that is of a certain height. Now, a high-rise building has become more usable or more popular because of elevators and with the advancement of technology. The discovery of the elevator has made it possible for people to move between various floors, to move goods and people between various floors. These are buildings with heights and also we also have to look at it from a fire and safety point of view. There are buildings which heights are beyond the reach of the firefighting equipment and can have serious impact on evacuation of occupants in emergency situations. A high-rise building is defined as a building with an upright floor located more than 75 feet above the lowest level of fire department vehicle access. Now, again, we can also talk about what sort of fire equipment we have in Nigeria. Because of the heights and numbers of the occupants, as I said, fire safety is a major consideration in the design of high-rise buildings. Now, we must also state that buildings taller than 40 floors are not necessarily defined as high-rise, they are defined as skyscrapers. What we have described earlier is shown in this image as regards fire access. Now, I want to go back and look at the history of high-rise buildings. How did they come about? Where did they start from? They date back as far as ancient Rome and the Roman Empire, where some of those high-rise buildings and towers were erected to defend cities. In a few examples are in Egypt and in San Gimignano in Italy. Now, some of these buildings at that time were made of wood and brick, so it was not uncommon to have failures in the structures in those structures. But like I said earlier, the discovery of the elevator and steel during the Industrial Revolution removed height limitations for this building. It was not possible to go much higher because we could frame the building with steel, which was a new material, which was not available for a long time. Several other social economic factors have contributed to the increase in the development of high-rise buildings. The increase in population density and the need to provide housing for that growing population. In the last, especially after the World War II, we've seen that there's been a global population explosion. Especially in Lagos now, we have seen what is happening with population increases in Lagos. The increase in land value in major cities and urban centers, also after World War II. So there was a demand for land and the prices were going up. Then also, especially in North America, there was competition amongst corporations to outdo each other in the height of their office building. So it was a case of, the bigger my building, the stronger my company should be. And marketing campaigns also, especially in the 70s and early 80s, promoted the the allure of living in the sky. So when you're up there, you have a good view, you're up away from everybody. So all this contributed to, helped in the promotion of high-rise buildings. Now with the, like I said, with the several high-rise buildings now exceed 100 floors, that's not even uncommon anymore. Height is no longer a anymore. As we have seen, if you travel to various places, the highest building now, the tallest building now is one that is in Dubai, the Burj Khalifa, which many people did not even think could be built. It is about 800 and something meters, 828 meters. So this sort of buildings are now quite common to see. Now, what is the design process for this kind of building? Now, there are several factors that should be considered by architects and building designers when embarking on this design and planning of high-rise buildings. This would be consequential to the success of that final product. And they would include, and this was mentioned by the previous speaker, Mrs. Okonjo, the permitted height regulations for such buildings in that location. What is the zoning for that location? This information is usually available through the local city planning office or gazette, and any restrictions therein, defined therein, must be complied with. The nature of the soil in that location. This will usually require a geotechnical investigation and analysis of the soil in which the foundation of the building will sit by a geotechnical engineer in order to determine the load-bearing capacity and other conditions of the soil, and therefore the foundation type to be used. Now, this is very important in a city where there's a lot of made-up ground. We hear this expression, oh, sandfield. So a lot of reclamation has been done. For instance, Parkview Ikoyi used to be a park, and it was quite swampy. That has been filled up. Even Banana Island was water, and it has been filled up. So it is very important in a city like Lagos that the soil, the nature of the soil is ascertained, and thereby the foundation type to be used is properly looked at. What is commonly referred to as a soil test is conducted, and it has now become a requirement by Lagos State for buildings of more than 2 floors. The design of the building structural elements based on a calculation of load to ensure its integrity and stability. The calculation is carried out by a registered structural engineer based on a design provided by the architect. The building should also be able to support its own weight and that of its occupants. So, I mean, again, that is the issue of the foundation and the framing of the building. Oftentimes, as Engineer Wale Ogundalu has said, failure is oftentimes a result of building failure is oftentimes a failure of the design itself. The building must also be able to withstand wind, load, and pressure. This might not be a large factor here, but in certain countries, there's a lot of wind pressure on tall buildings. Then also, when you're putting up a building, a tall building, a high-rise building, what will be the impact of that building on its locality, on its environment, on other surrounding buildings? An assessment of the impact of that building is usually required. And this will regard the scale of the building, the vistas when thereafter, once the building is done. Is it going to block any views? The airspace to other buildings will be required by the planning authority, especially when the site is constrained, and if neighboring structures like heritage buildings, listed buildings might be affected by the proposed building or by the construction that is planned. The proposed building must also, in the design, respect the character of the existing area and maintain the distinct identity of the place. So you can't be in a purely low-rise residential area, and then you want to plunk in 15 floors, you know, against what obtained. Study is very, very important to be done. Then mechanical, plumbing, and ventilation requirements for the building. Now, these are usually done for most buildings, small and large, but they are particularly important for high-rise buildings because of the large occupancy and the complexity of the network of these building services. Several of these services are also designed to achieve good efficiency for the building. Recently, in the last 10 years, the last decade, people have been talking about global climate change, sustainability, energy efficiency, and environmental friendliness are now designed into many buildings. LEED standards and certification are now commonly desired and are achieved. This is now also becoming quite, it's catching on in Nigeria. There's a demand for this sort of buildings now. People want to save energy. People want to protect the planet. And why should my building use so much energy? Then also the building brand and the aesthetics. Every building of that nature has a client. The client's vision must be enhanced and projected by the building's design and choice of material for the interior and exterior of the building. And safety and comfort of the occupants must be built in through adequate natural and artificial lighting, ventilation, fire prevention and protection, as well as clearly defined fire escape points. Vehicular access, circulation, parking, as well as other factors that will enhance the safety and comfort must also be of utmost priority. A full complement of experienced building design consultants must be engaged on the project. A few of the previous speakers have spoken on this, to provide design solutions for all the factors listed above. This would include the architects who initiate the design concept, the structural engineers who design the building's foundation and frames, the MEP engineers for the various services that make the building comfortable. Then oftentimes there are specialist consultants who handle several other aspects, like we have spoken of the soil engineer, fire safety and detection, egress, that is how to get out of the building, security, information and communications, etc. Large volumes of construction drawings and documents running into hundreds of pages are produced by the various consultants in order to obtain necessary planning permits and for the construction work. To embark on such a project without the involvement and participation of such a team is most often a recipe for failure. Now, it is not uncommon in this country for documentation, for people not to even consult, not to engage consultants. Oftentimes, consultants are even seen as an additional cost to the project. So a lot of clients try to do without them. Oh, I don't need that extra cost. It's not just to do a design or just to do a drawing, but it goes far more than that, far deeper than that, as we have seen. Their input and their contribution is very, very crucial. Beyond preparing the various drawings and specifications for the building work, this team of consultants will also be further engaged to extend their services to the inspection of the construction work being done by the contractor on an agreed and frequent basis. This is the best practice. But sadly, we have heard of many projects that don't even have consultants involved. They don't engage the expertise. Oftentimes, it's because the developer doesn't see the benefits of paying the fees, or simply, I've done it before. I can do it myself. I've done it somewhere. Nothing happened. It can be done again. So they did 2 floors. Nothing happened. Oh, okay. I can do 6 floors, and then I can do 10 floors, without necessarily having the required skills or without having the backing of the expertise of consultants. Also, sadly, the system has often shown a lack of will to even deal with those kind of situations where projects don't have consultants engaged. The system tends to look away, and sometimes there's no law that compels him or her to engage consultants. So again, we talk about regulation. What are we allowed to do? What can you do? What is not allowed? Now, what are design and planning standards? What are the standards that we're talking about? These are sets of guidelines that have been defined by regulations over time, and they must be adhered to in the construction of the building. These guidelines are in place to ultimately allow for the optimal integrity of the building, safety and comfort of the user. In defining, now what happens in other parts of the world? what is globally accepted? I'm going to focus on North America, which is where high-rise buildings became very popular before Asia now took over, and they seem to have a lot more of those buildings. Now, North America, in defining globally accepted design and planning standards, we cannot but ultimately do it in a manner that we relate them to our local situation. So when we look at what happens in North America, we also have to compare it to what obtains in Nigeria. What is different? What are we doing differently? Why are we having all these issues, all this building collapses? As a result of, now, North America is probably the continent where high-rise buildings were made acceptable to the whole world, but it has also recorded the most mishaps and casualties from this building type. They've also had fires, they've had collapses, they've had terrorism, they've had loss of life. As a result of, and in order to prevent or reduce this unfortunate incident, they have developed several building codes that guide practically all requirements for the various elements of the construction of high-rise buildings. So there are codes for almost everything: the use and occupancy, the site setup, pedestrian safety, building height, fire, smoke, type of construction, and so on, many more. Plumbing, elevators, the steel, the materials, the roof structure. Everything has a code that must be met. And the process for approval is pretty straightforward as well. So you have all this code that you must adjust. There's a document that tells you what is required. This document is very familiar. A lot of the consultants who are involved are very familiar with this document. They are conversant with what needs to be done. Now, what is the process abroad? The drawings and documents are prepared and certified by consultants. The design process. The process of design and planning is made less cumbersome because there's information to be obtained. There's things you want a code, you can Google it, you can make a call, it's online, you can get it. And then the advancement of technology through new software makes the design now of high-rise buildings fairly easy. A lot of things have become standardized. For approvals, a registered architect or professional engineer, as the case may be, submits the plans and documents to the relevant department of the city for necessary approval. Now, this third aspect is very important. The contractor. Once the building approval is issued, that is an approval that you can actually build the structure, a licensed contractor is appointed. It is that licensed contractor who applies for a permit to build. So he will obtain a work permit to start construction work. Without that license, even when you have approval, a contractor cannot start work. It is important to know the requirements and role of the contractor in this context. The contractor for a high-rise building must be licensed by the state and will be the one who is issued a permit to construct. And inspection. Upon commencement of the work, the contractor will invite various city inspectors to check and approve the various stages of the work. For specialization and efficiency, these inspectors are mostly professionals drawn from the private practice. They're not necessarily city employers. Numerous inspections and special inspections by these officials from various specializations will occur during the course of the construction. So there might be an inspector, for instance, for foundations only. There might even be an inspector for steel work, an inspector for glazing. These are specializations that cannot all be under the city because they can't have people who have that much knowledge about all these aspects. These inspectors stringently check all compliance with the relevant codes and standards. Approvals to proceed are granted once the work is deemed satisfactory. Under no circumstance can the contractor proceed without this approval. All inspection records are signed, electronically documented, and archived. Now, what obtains in Nigeria on a regular basis, on a normal basis? we're talking about land use and demand on land. As mentioned earlier, increasing land values in cities and population growth have led to an increase in demand. Lagos, Nigeria is not any different. It's where hybrid neighborhoods have witnessed an increase in population and a significant rise in the rental value and cost of land. I mean, somebody was telling me some days ago that, oh, Banana Island, for instance, was 10 million from 2 decades ago. Now, they're probably talking about 600, 800 million per plot. You can then look at what that means. So the table below shows population growth of VI and employee. This is from the Lagos City Model Plan. In 1991, Victoria Land had 40,000 people. The projection for 2025 is about 1.7 million people. Ikoyi seems to follow the same kind of trend. Ikoyi used to be low density, quiet neighborhood, but that seems to be changing. There's a new Lagos City, a new Lagos Model City Plan. There's one for Ikoyi and Victoria Land. There's also one for Ikeja. Those are considered urban centers in Lagos. There was a lot of frustration and pressure by landowners and developers on the state planning authorities to lift existing restrictions on height, which many developments had already begun to contravene. In a place like Ikoyi, I mean, there were people who felt, if I paid so much for this land, why should I just put 1 unit on it when I can put 6 units? So flats were starting to come up. Flats were starting to be built on a single family plot of land. In response to this changing demands and other future development objectives, Lagos State introduced a model city plan document for Ikoyi and Ikeja in 2013. And interestingly, and to the dislike of some parties, this new master plan changed the permissible heights for buildings in large segments of this neighborhood. High-rise developments of up to 110 meters or 30 floors are now allowed on some streets in Ikoyi and VI. This is a page from the new approval order from the Model City Plan. The recent unfortunate incident that we had that occurred on Gerard Road. If you see from here, if you look at row 4, Gerard Road is now 110 meters permissible. Units per hectare is now 150 units per hectare. So that sort of tells you where we're going, what the future holds in terms of building heights in Nigeria. So in preparation for this master plan, Lagos State had a review. The Lagos State Assembly enacted a law in 2010 for the administration or regulation of fiscal planning. So they basically broke up the Ministry of Fiscal Planning, not broke it up, but they created new departments within that ministry. So they have the Lagos State Fiscal Planning Permit Authority. They are actually the ones that issue building permits to intending developers. Then the Lagos State Building Control Agency. Anybody who is in construction in the building industry would have heard of LabScan. They are very popular. They have the authority to regulate, to enforce, regulate, and inspect buildings under construction. Now, the process is not different from North America. Drawings are prepared by registered building professionals for submission to LASPA. All required documents are submitted and an assessment fee is calculated. The necessary payments are made. The town planning officer visits the site to confirm that the site is actually free and ready for construction, and it is what is shown on the survey. Now, once the drawings and inspections are agreed, an approval for a building permit is issued. In all this, there's no demand for the involvement of a licensed contractor. So you put in your drawings, you put in your application, everything is reviewed, and you're given a permission, a building permit. Now, there's no question of, okay, who is going to do the building? So that is left entirely to the owner of the property to invite supposedly, hopefully qualified contractors. Now, in North America, for instance, the building permits, differently from North America, the building permit process here also needs to be reviewed. It sometimes be vague, tedious, and cumbersome. It needs to be made easier. The main player in construction regulation is LABSCA, and they are saddled with duties as described below. The contractor is expected to notify LABSCA of their intention to commence construction. Now, the way it works is that once you have your building permit, you should notify LABSCA that we are about to start. Several times, this expectation is not readily conveyed. Every key stage before concrete placement, so contractor should inform LABSCA of the intention to commence construction, one. At every key stage before concrete placement, where the agency will visit to inspect the placement of reinforcement bars. Then they should also be notified of the completion of the project. Then any significant plan changes to the approved design, tube test results, and tensile strength results for the reinforcement. Now, because the system is different here, the inspectors are salaried staff of the agency. There are delays in scheduling. There could be delays in scheduling inspection. There are manpower shortages, and also the delays could also come from the contractor, who either doesn't understand the process or has not given adequate time. A considerable bit of work is required to make the process more streamlined and more effective. Current methods of enforcement of planning regulations are generally not deemed as purposeful or corrective. So you have your building, they've come to mark your building, and you start to question why they're there. You're not even sure why they're there. And oftentimes, when people see that the building has been sealed, so it's revenue generation. Gladly, in recent times, the Federal Fire Service has also been involved in certification of buildings above 2 floors. But this involvement still needs to be clearly defined and better harmonized with state planning regulation processes. This is the Federal Fire Service, not the State Fire Service. How well are they working with Lagos State? Are people notified or informed of this requirement when they put in their application to Lagos State? Now, Mr. Ige spoke about something, about regulations, about codes, building codes. One of the major challenges we have right now is that there is a lack of an updated and approved national building code. There are several editions, but there's not one yet that has been approved by the National Assembly. This should contain all the necessary codes that will guide the building industry in Nigeria. Now, in conclusion, the question I will ask is, what can we do better? Some of the differences in the standards adopted have been mentioned earlier, but there are things that we need to improve upon, and this needs to be done urgently. There's a lack of knowledge by the general public of what is required. Continually educating the public of what is expected and the possible consequences of not engaging qualified professionals for projects. Regular town hall sessions are a very impactful means of achieving this. Providing ease of access to all necessary planning guidelines for the process of obtaining building development permits. Electronic means of sharing information and data will make the world of difference. A few years ago, Lagos State created an electronic application portal for online approval applications. But oftentimes, there are technical glitches, so people now end up taking their manual applications for submission. When the rules are clearly defined, they will become easier to adhere to. Making the process more streamlined, where documentation is better shared between oversight agencies. Developments that are compliant are sometimes marked for contravention because the approved documents were not passed or shared to the enforcing unit. So I've seen situations where one agency is not even aware that you're on site, or they're not even aware that this building has gotten planning approval. We must also create a system of licensing all contractors and ensuring that permits to build high-rise buildings and other large buildings are only issued to licensed contractors. Construction should not be accident waiting to happen due to incompetence. Empowerment of the building industry, empowerment of building industry professional bodies to ensure that only registered members of these bodies can and should oversee such developments as described. And there should be periodic interface between the building industry professional body and the regulatory agency. There are several proposals that have been put forward. Approval means that were introduced, but they were not followed. Things are still done before this. And there's a slight disconnect between the professional industry and the agency. The urgent approval of a new national building code that will become a guidebook for all building development. Enlarging the building construction regulatory and inspection agencies by engaging experienced private sector professionals as part of the mandatory inspection process. This should make the process more robust and building more effectiveness into the process. Ensuring that all stages of the construction work for all buildings, especially high-rise and tall buildings, are seriously inspected from start to completion. This will be from the pile foundations done, for instance, right to the roof elements. It's not just to walk into the site and sign a paper, but everything should be checked. What is the concrete mix? What is your, what was your pile load test result? Did somebody witness the pile load test? Making the entire approval to inspection process to be more purposeful with care intention. Oftentimes, a building that has been sealed for an obvious conservation is seen to be unsealed without the removal of the contravention. This is very common in Lagos. There are buildings that have not observed the required setback. It is glaring, it is obvious to everybody. The building is sealed, possibly for that purpose. And in a couple of weeks, the construction resumes, and that contravention hasn't been seen to have been put right. This may encourage belief that rules can be bent to one's pocket. There's certainly a lot more that can be said today regarding design and planning standards that are applied globally and locally, but I want to believe that we have managed to touch on the key factors that are considered in the process. Thank you very much.
Thank you very much, Architect Olumide Odukale. Thank you for those valuable suggestions as well. I can see some feedback in the chat, people saying and resonating, that your points are resonating with them. So thank you for that. Just as a reminder, this is being streamed on our social media platforms, on First View YouTube channel, Facebook, as well as other social media platforms. And this is brought to you by the Nigerian British Infrastructure Group, a subset of the Nigerian British Business Forum based here in the UK. I would like to invite our lead architect within the Nigerian British Business Infrastructure Group and one of our second to the last speaker for today. I want to also appreciate those people who have been on. I've seen a total of well over 100 people that have been in and out of the room. Thank you so much for joining. And for those who have stayed with us so far, thank you very much for staying with us. We really appreciate the time you've taken out on a Saturday to be with us. So without further ado, I would like to invite Engineer Dapo Sulu, who attended the International School Ibadan and graduated from Ahmadu Bello University in 1983 with a bachelor's honors in civil engineering, postgraduate diploma in 1992, and MSc in geomaterials in 1995 from Queen Mary University, University of London. Is a chartered engineer and environmental manager, and currently practices as an engineering consultant in UK and West Africa. As previously mentioned, he is the lead architect within the Nigerian British Business Infrastructure Group. Please help me welcome Engineer Dapo Sulu. Thank you very much. And Architect Odukale, do you mind stop sharing as well, please? Thank you. Engineer Dapo Sulu, over to you, sir.
Hello, good afternoon, everyone. Greetings to all who have taken time out of their busy schedules to attend today's meeting. It's greatly appreciated. I'll just give a brief rundown of my topic. And my topic is, what are the environmental factors that affect high-rise building projects? Just to give you a background on me and my career so far, I am a civil engineer, chartered engineer, and I've worked in various phases of projects and with various companies as civil engineer. And currently I specialize in environmental management. So I'll just give you a brief rundown on some of the factors which I think should be considered when one is undertaking high-rise building projects. Designing a sustainable tall building requires a total view of the entire building enterprise, considering the local and global environment, availability of renewable and non-renewable resources, decent community impact assessment, and the collaborative input of architects, engineers, planners, social scientists, and other community-based groups. Now, the life cycle of a typical structure involves the following stages: planning, design, construction, operation, maintenance, renovation, and finally be positively affected by environmental factors. There are several ways in which a building can be affected positively or negatively by sustainable procedures and processes. Such procedures are focused on the environmental efficiencies of the structures and include the manufacturing of recycled materials, structure erection methods, together with buildings' overall operations. In the current era, climate change, air pollution, depletion of biodiversity, and deterioration of the urban environment have become global issues. Accordingly, the construction industry is continually seeking new and innovative ways of creating more affordable, efficient, functional, and sustainable materials within high-rise construction. Currently, the most prominent trend within the high-rise industry is the utilization of existing energy through sustainable design means. High-rise structures use energy across their entire life cycle, from construction to demolition, as I just mentioned. So there is an increasing trend, in investing in building energy efficiency, or what we call zero energy design. These innovations aim to further improve energy efficiency, together with creating increased productivity in buildings, reduction in construction impact on the surrounding environment, improved building efficiency, also have a positive impact upon project site, energy and water usage, materials and resource conservation, and improve the overall indoor environmental quality. Environmental factors can positively influence high-rise construction in 5 areas. The sustainable constructability includes all the planning, design, construction, operation, maintenance, renovation, and demolition stages. Structural performance specifically deals with the load-bearing integrity of the structure. You have innovation and design process, which deals with pioneering modeling techniques and procedures. Sustainable maintenance includes various preservation methods which further prolong a structure's life. And finally, the materials and resource effect, and also take into account the recyclability, environmentally friendly, and conservational aspects of green structures. A full integration of engineering and architecture is crucial. I mean, as mentioned by some of the previous work on high-rise building, and if we all put our heads together and effectively plan these buildings, they end up becoming more efficient. I mean, a well-integrated high-performance building may incur slightly higher initial costs than a regular one, but these costs may be offset by much lower operating costs. For example, the facade of a building usually covers up to 90% of the external building surface of a tall building. So the choices made in designing the facade have a massive impact upon energy gain or loss. For example, look at the tallest building in the world. That's the Burj Khalifa in Abu Dhabi. Now, that building is probably, I think, 828 meters tall, if I'm not mistaken. And the facade employs a special type of glass. Now, obviously, it's built in desert areas where heat is a significant factor upon the area. So a special form of glass was designed which actually blocks out ultraviolet light to a certain extent. As a result of this, initial cost of the glass is probably higher than would normally have been the case. But because the temperatures in the building are much lower than would otherwise be the case, therefore the maintenance costs of ventilation of the building are much lower. And that's where the savings come in. Harnessing solar energy. We have passive solar energy, which includes direct to indirect space heating, daylighting, and so on and so forth, and active solar energy, which involves technical installations such as solar collectors and photovoltaic panels. If a building, let's consider typical high-rise building in, let's say, a place like Nigeria. They tend to use large generators. These generators initially may be a lot cheaper than installing solar panels and other renewable energies. However, the maintenance costs and running costs of these this equipment tends to increase with time, and also due to the increase in and improvement in technology, the cost of solar energy installations is decreasing. So therefore, there comes a time where the cost of installing and using generators and other such equipment may become much more expensive than actually designing and installing solar energy panels, for example. That's something we can consider. Also, harnessing wind energy. Tall buildings can be shaped to funnel wind into a zone which contains wind turbines that can be used to increase the available energy and can be used for either heating or cooling. Some of the other issues involved in tall buildings include combined heat and power. In some of the more temperate areas of the world, there's a combination. Heat and power systems are combined, and they do tend to lead to low overall costs. There's also the use of fuel cells, biomass technology, geothermal energy, that's hot water from springs. And these tend to reduce the overall running costs of high-rise buildings. Also, there are other issues which potential toxicity of materials being used and things of this nature. We all know that in tall buildings, one of the major issues is ventilation. And if a tall building is not properly designed, there could be problems with indoor air quality. So therefore, these environmental factors need to be considered during the design of a tall building. Moving on, finally, there are a few questions which should be asked by anyone who is involved in the design of a tall building. For example, what kind of site will the project be built on? Is it going to be a greenfield site where nothing has been built before, or on a brownfield site where maybe buildings were demolished? That is going to significantly affect the foundations and below ground requirements. I mean, some of the previous speakers have mentioned about piling and piling foundations. These are things that need to be considered during the life cycle of a project. And there are environmental concerns which could be brought into bear in this respect. So these are things that need to be considered. If you have high-rise buildings, your foundations have to be up to spec. This will also depend on the kind of ground you're building in. If you're building on rock, your foundations may not need to be as robust as if you're building in soft or wet ground or near a coastline where there's could be proximity to waterlogged ground. The area that you're building in, if it's subject to earthquakes, sinkholes, or subsidence, that could have a massive impact upon, once again, foundation works. Obviously, some of the previous speakers have mentioned about piling, about foundations, about things of this nature. These are things that need to be considered. How will electricity, water, and sewage services to the buildings be supplied and managed? It is a significant endeavor to get to a high building, something of 10, 15, 20 stories. These are things that need to be considered. Also, average ambient temperature. A building, a 12-story building in Abuja will probably need to have different set of, need to be built in a different way and have different factors compared to the same building built in Alaska or London, for example. One needs to consider wind loading, ambient temperature, sunlight levels, and so on and so forth. So also something which is very significant is also during the construction phase, a lot of concrete is used on these various buildings. One needs to bear in mind that concrete needs to set and cure, and the times which the periods over which concrete needs to set and cure differs between the various areas within which one needs to one carries out one's construction. Obviously, the concrete would probably take a different time to cure, maybe in somewhere like Abuja compared to Lagos or Alaska. These are things that we need to be considered, and the environmental aspects of the construction that need to be borne in mind. Finally, as mentioned by the previous speaker, what's the various rules and regulations in terms of building regulation and planning permission? These do need to be borne in mind. For example, during my career to date, I worked with various environmental organizations. I worked on a project once whereby we had to actually delay the start of a scheme for 6 months because there are certain wildlife which gain access to our site. For example, in Britain, there are environmental regulations which permit the movement of nesting birds or protected species, and these are strictly enforced. We worked on a project whereby we had, I think it was newts and bats gone into an excavation which we carried out. And because of the rules and regulations in Britain, we could not touch these things, and we had to put the project back 6 months. These are rules and regulations which had to be strictly enforced and strictly adhered to by the contractors with whom I worked then. It's when countries have strict regulations in terms of whether environmental, building control, planning, and so on and so forth. When these rules and regulations are followed and adhered to, then within those rules and regulations, then that is when the development and production of buildings tends to be most efficient, and that way there seems to be fewer incidences like the unfortunate ones which tend to happen in Nigeria. So by and large, I think we're going in the right direction, but we need to always ensure that all the rules and regulations which are in place are strictly followed. That way we end up with best practice, and the buildings we actually build tend to be the best that way. Thank you.
Thank you very much, Engineer Dakwasulu. I don't know if you can hear me. Your screen froze towards the end of that, but thank you for that insight as well. I looked through the messages and noticed that there was a question about the outcome of this presentations and if it will be presented to the federal government and the state government, especially the Lagos state government. I can confirm that we will be putting out a communique which will be going directly to the Vice President as well as stakeholders within the Lagos state government moving forward. So we have a last speaker. He's going to be wrapping up this session, and then hopefully we have a couple of minutes to take a few questions. But if we don't have the opportunity to take questions, please do reach out to us directly on our social media platforms. You can reach us on Nigerian British Business Forum. We're on Instagram, Facebook, and you can also reach us on the First View TV on YouTube, the YouTube channel, First View TV. And there you can put in the comment section your questions. We have a team dedicated to compiling those questions, and we will endeavor to reach back out to you with the answers as well. So I would like to invite at this point, Engineer Tomi Adebayo. Engineer Tomi Adebayo is a civil structural engineer as well as a building control consultant based in the UK. With over 35 years experience, he practiced in Nigeria in his early career and then moved to the UK. Engineer Tomi was a principal structural engineer in local government building control for 15 years and now runs a firm that provides structural engineering support to building control approved inspector firms. He will be contributing mainly to the possible regulatory practices that would reduce the risk of collapse in buildings generally, and specifically for high-rise structures. I'd like to welcome Engineer Tomi Adebayo. Can you hear me, sir?
Yes, I think you blocked my video. I can't start the video. Yes, I can hear you.
Okay, awesome.
Yeah, have you unblocked my video? I think you.
Okay, I will work on that, but can you see your presentation?
Yes, I can see my slide. Yes.
Okay.
Okay. Good afternoon, ladies and gentlemen. It's rather ironic that building control is the last speaker today. But meanwhile, if anything goes wrong, building control are one of the first in the firing line. As you can see, what happened to one of our colleagues in Lagos State when this thing went wrong. My sister did say, "Why are you the last speaker?" I said, "I don't know." Building control is probably a rather boring topic, but building control is your friend. We are here to protect you from all sorts of things that you don't really understand. Now, in my words, building control is the process of ensuring that construction work is done to a national standard, starting from the design stage and right through to completion on site. A lot of people do not understand the difference between building control and town planning. Town planners are things to do with zoning, what can be built in a particular area, and where a building is supposed to be located and what that building is used for. Building control are those people that are more technical people that make sure that things are done in the right way and to a particular standard. Nigeria does have a national building code, but that building code probably needs to be worked on in terms of it needs to have some supporting supplementary guides that can apply locally in different areas. Something that applies in Ikoyi will not apply in Abuja, will not apply in Ibadan, and will not apply in some other parts of Nigeria. So those documents need to be sort of supplemented. I've gone through the National Building Code. I wouldn't say it is deficient, and I think it probably needs to be enacted because it's not enforceable by law. Now, some of us have gone through various definitions of a high rise, and it does vary from country to country. But I think it should be related to the capacity of the fire authority in each country. In a country, Nigeria, where I don't want to say anything negative about the fire authority right now, but I can say that it's not quite as advanced as you would expect in probably North America. So if we are building 100-story buildings, 200-story buildings, we need to bear in mind that we are going to have challenges if there is a fire on the 45th floor, and how exactly are we going to deal with that? So in my opinion, now, these are the processes of building control. There are processes that have to happen before construction. Before construction, Wale Ogundalu has mentioned some things, Engineer Igi has mentioned some things, in having the architect's drawing, in having town planners, QSs, and all these people are involved before this thing comes to building control. The architect produces a detailed plan. The architect thinks of how people are going to get out of the building in the case of a fire. Let's move to the next slide. Now, after the architect has done all his nice looking drawings and it looks pretty and is well presented, which attracts end users to want to buy these things, then the structural engineer has to see how this building is going to be built safely, how it's going to remain under all sorts of loading, just like Wale has said, columns, pillars, beams, lift shafts, roofs. Somebody has to make sure that all these things are strong enough to withstand all the loads. When we talk about dead loads, we're talking about the actual load of concrete, of the structure, the actual weight of the structure. And when we're talking about live loads, we're talking about things like people that are going to be in there in the final analysis. Now, what happens is, just like you've all said, when you're talking about specialists, the problem with building control is that all these specialist drawings are sent to a building control section. And when they're sent to the building control section, do they actually have the skills to check these plans? Do they have the skills? If I'm talking about finite elements method to a building control officer in Lagos State, does he really know what I'm talking about? If I'm talking about piling, I'm talking about second piles, ground piles, all sorts of piles, does he really know? I can see architect Odukale said something about private sector involvement, because you do need these sort of people, because these things are beyond the skill of the day-to-day building control officer anywhere in the world. In UK now, we have approved inspectors that are actually in the private sector and are regulated by a national body. Let's move on. Now, during construction, you also have inspectors from building control that should have copies of the approved plans with them. So they have a copy of the plans. Like, okay, Engineer Ogundalu has said, this foundation is supposed to be this deep. This column is supposed to be 300 by 400. The reinforcement is supposed to be 20 millimeter at 200 centers. And that is what he's got in front of him. Yeah, and that is what he's supposed to be checking. Now, when you're talking about specialist things, particularly high-rise, there are some things that could be beyond the skill of a standard building control officer. If you're looking at connections, if you're looking at, as I said, steel reinforcements, some of it are very complicated. What steel needs to be at the top? What steel needs to be at the bottom? What are the shear links? All sorts of things that in some countries, like probably in UK, a structural engineer goes out to do the structural checks, and then you bring in all sorts of consultant building control officers to look at other things. Now, after construction, Lady Udo mentioned something about due diligence, and that is because sometimes a a building or a flat needs to be sold, you want to buy a flat and you want to know that that flat you paid $1.2 million for has actually been checked, it has been audited by somebody, and there is a sort of certificate that you can use in future to say there is some sort of assurance that this thing has been done properly. You might have to take out an insurance to insure the property against fire, against different things. And those are where having a completion certificate shows that at least a level of assurance has been adopted in this property. You have to have a situation where you have as-built drawings, so you can refer back in future. Now, I use the word effective building control because building control cannot be effective if the officers are not qualified and experienced in high-rise design and construction. Yet again, that can be helped with the private sector. You have to have building control officers that have legal powers. So, like architect mentioned, the National Building Code is not enacted. In UK, the building regulation has an act, the town planning have an act, and they can lock you up, they can do all sorts of things, they can seize you, they can freeze your accounts, they can, anything they can do when you don't follow the law. They must have reasonable access. That means you can't just lock out a building control officer and say, you are not coming here. We saw some ugly incidents in Ikoyi. You know, you never know with social media whether that is correct, but it seems like they were refused access to the sites. That is not really good. Now, we must not ignore the elephant in the room, which is corruption. Yeah. And this happens anywhere in the world, it's not just Nigeria. And there have to be some methods, some checks and balances in which we can use to make sure that these building control officers are of high integrity and they are fair. They're not just going to people's sites and locking them down for some other reason, which I would not mention, but we all know the sort of reasons that some of these guys will come around and just generally just lock you down. Building control officers must have safety equipment because they're working in a high-risk area. You can imagine you're working on a high-risk structure and somebody drops a bolt from 20 floors and it lands on your head. You're not going to survive that. Building control officers must be able to take records on site, and those records have to be saved safely. So not just paper records, those records have to be on a computer, because in future, we might have to refer to those records. Now, what are the problems that building control face? One of the problems they face is, yes, they lack adequate enforcement. In fact, they lack any enforcement powers in some cases. I think some states probably don't even have building control. I think this unfortunate incident has focused our minds on building control in a way that we didn't. Condolences that some people lost their lives and this happened, but in every cloud there is a silver lining, and this might be an opportunity for us to really look at some of these things and really make sure that this sort of situation, which is almost an embarrassment to the country, doesn't happen again. Now, software, like we said, somebody has designed a very complicated multi-rise structure with thousands of pages and has just dumped it in front of a building control officer who doesn't have the software, he doesn't have the skill to check them. So therefore, it is important again that we have equivalent people on the other side that are checking. In UK, just like Kayode has said, the developer himself has his own checking in-house checking. He's not relying. It doesn't matter that somebody has a PhD from Imperial College. It doesn't matter that he is a whiz kid. people make mistakes, omissions are made. Therefore, we should have an adequate and equivalent person checking sophisticated designs. Now, what we have in most of cases of these high-rise buildings, they are designed by top consulting structural engineers. But despite that, in the countries like UK, they will not say, okay, because it's been designed by Arab, there's nothing wrong with it. They're experts. They know exactly what they're doing. So if the Arab says it's good, it's good. No, they will find a company of the same caliber as Arab to check it. They mentioned a company called IIS in Nigeria, who is run by an engineer, Akintilo. And I found that, yes, this is somebody of very high caliber. Now, we need to also set minimum standards for these structural engineers, yes, not just being a membership of COREN, because COREN encompasses a lot of engineers. I remember when I was a youngish engineer in the beginning of my career, I had my senior manager used to stamp my calculations when we are going to take them to the town planning, and he was an electrical engineer. He had this nice stamp, and he would just stamp it, and he would just look at me and said, "Are you confident this is okay?" I said, "Yeah, of course it's okay," and he will stamp it. So we probably need to be a bit more specialist in saying, not just qualified engineer, they have to be qualified in this narrow field of high-rise structures, not just any engineer. And that cannot effectively be done by building control. In this country, most developments are financed, and the finance company will do their own due diligence. They will ask to see who is going to be the engineer for this project. They will look at them and say, you know, what is your turnover? Have you done this before? This and that. And what they will do, they'll just put an astronomical insurance fee on the job to say, look, we don't know these guys. They're not competent. And then the developer will say, why? Well, because, you know, this guy you put in front of us, we don't think is up to the job. So, but in Nigeria, I don't think we have that. So now we have to, when we have building control, they have to have specific teams. They have to have a sort of high-rise team that deals with high-rise structures. So you don't just send any of the building control guys. You have a team of specialized building control officers. And if you don't, then we need to go again to the private sector. So I might be overselling this private sector thing, but I think that because of the level of influence on local government and state building control in an environment like Lagos, where they have all sorts of political influence, it is not that easy for them to be able to do their job in a fair environment. And when we do empower these building control officers, it is also possible for them to abuse the power, because now we've empowered them. Now they're going around locking up everybody's sites, knocking down everybody's buildings, which I think probably they've started to do, which I think is an over knee-jerk reaction. We shouldn't really be doing that. We should, like I said, have supplementary documents to buttress the building code so that it makes it easier for the building control officers that are not specialists in something. Just guidelines like Ikoyi, Victoria Island, we expect the foundations to be pilot foundations. Now, in order to help develop building control, we should have a lot more training. I think Kay also mentioned something about education. And we have to educate these people. We have to invite them to seminars. We have to have open webinars where people will talk on a specific aspect that helps people with to gain that knowledge on high-rise. And now we've emphasized so much on the structural aspect, but it's very, very important. There are two very critical parts of what we call the approved documents in the United Kingdom, which are supplements to the building regulations. And in the approved documents, the part A of the approved documents deals with structural, because structural is probably the most important. And then part B deals with fire. It is very important that you have a fire on a 40, 50-story building. You don't even have fire brigade access to where the building is burning. You know, that's just disaster. Minimum qualifications for the building control, diplomas, degrees, past experience. Somebody has to set up a framework where we expect that a building control officer has a sort of minimum qualification. But most importantly, that person has to be very willing to learn, because building control is live and it changes all the time. Now, state governments should, as if they don't have the powers to lock people up, I think one thing they could do is shame them, you know, just like they used to do in the olden days. So is no longer a member of our company. We've sacked him. Don't do any business with this person anymore. So Lagos State government should say, this building is not safe, and anyone that purchases or occupies this building does so at their own risk. I think if one or two developers have that stamped in a national newspaper, I think a lot of them will probably start to behave themselves. Now, a national health and safety body. That is going to take a long time to implement. We have been having high-rise buildings in Nigeria. The first one I was involved in was 1983. Eagle House is still standing there. So this unfortunate incident was a one-off, but we should at one stage have an enforcement body that has serious powers. Like I said, the Health and Safety Executive in UK can freeze your account, they can suspend you as a company director, they can actually make you have a criminal record, which can ruin your career. So these people have very serious powers. We should also have a situation of where we could have a whistleblowing website where you can actually go and as a member of public just show, or as an engineer that's seeing something that is not, and just send an email to Coren to say something bad is happening there. Now, if we now look at the recent disaster, what people have been blaming the structural engineers, but the structural engineers designed something for 6 floors, and that 6th floor went to 8, 10, and ended up as 21. No matter how much factor of safety the structural engineers could have put into that structure eventually had to obey the law of gravity and come down. Now, if building control had more powers, probably. It's all about risk management, yeah? These things could have been, the risk could have been reduced. So everything that's happening within high-rise is layers of safety. In UK, you have 4, 5, 6, you have CDM, like Kay mentioned. If CDM will pick up who is the engineer, who is the architect, straight away, you know, no, we can't have Mr. Blah, blah, blah as architect. He only left uni 2 years ago. We have to have them to have specific experience, train them. Even if we have to send them abroad to go and shadow, let's hope they come back if we do send them abroad. But if we do send them abroad, to Dubai, to India, to Chicago, just to see how things happen so that they can come back and pick up some international standards. Yes, again, I say third-party private sector engineers in anywhere in the world is very difficult to have a local in-house building control that can deal with sophisticated buildings such as high-rise. They have to be supported by the private sector. It's just one of those things. There are some things that that I probably haven't been able to mention, but thank you, and I'll just expect questions from the members of those people that have taken out their time to attend. Thank you very much. Bye.
Thank you very much, Engineer Tomi Adebayo. There were some questions around the gaps between the UK, US, and other parts of the world versus Nigeria, but I think you've touched on some of it in your presentation around the building controls, and that's so insightful. Thank you very much. Now, I'm conscious of time. We are over time. We're 15 minutes over time at this point, but I think there's a question here, and this would, on the hot topic of the Ikoyi collapse, that I think it will be good to just briefly touch on. And if we can have every speaker just provide some sort of insight based on their own professional experience, and make sure you also touch on the regulations, if there were any sort of regulatory blunders that were existent in the present investigation. We know that it's still ongoing, it's still an ongoing investigation, but it's key. There's a question here that says, was the Ikoyi collapse a failure of building control or corruption in the system, or even both? How an 8-story building ended up with 21 floors is a mystery for a lot of people. So I think it will be good to have architect Olumide just quickly from his own standpoint, what are your thoughts around that question? Is this a mixture of corruption or building control, or singularly building control? So if we start with engineer architect Okale. Yes, sir.
Thanks again. Because there's a panel of inquiry ongoing that is sitting, I think we should be mindful of expressing opinions, professional opinions on this matter. It is very unfortunate, but what I would say, I cannot say whether there were oversight failures on behalf of the regulatory body, and I can't say whether it was a structural failure. For now, I mean, immediately a building like that comes down, the first thing that comes to mind is, the structure has failed. If you watch the first video that came on air on social media, there were comments by people there, oh, look at, see the iron with them used, you know. So everybody becomes an expert. Now, again, we need to have regulation, and we need to have a system whereby not everybody who is a developer becomes a builder. In this particular instance, what was said is that the project signboard did not have any known names as consultants. There was just phone numbers. That shouldn't have been able to fly. So, I mean, it's little things like that that may suggest that there was a failure in regulation and in oversight.
Thank you. Mrs. Udo Konjo, you run an organization that is based in Ikoyi, and you've done quite a lot of high-rise buildings in Ikoyi specifically as well. What are your thoughts around that collapse, and your thoughts in general?
Thank you, Sean. I mean, obviously there's an investigation and we will have to let it run its course. I will speak more from the perspective of if I was representing a buyer or, you know, asking those questions about the 5 W's once again. If investors had asked the question, who are the contractors? You know, Mr. Adebayo was talking about specialization. So clearly, when you're building a 20-story tower or building, we're talking specialists, contributors, stakeholders, builders, all of that. So on the face of it, it appears that was not the case in this particular project. But we would have to wait, you know, to see all of that. My key concern, however, is from the commercial and financial side. We have to remember that there are people who have invested in those properties, you know, that are no longer there. Insurance, contracts, there are people who supplied, you know, so really what we're talking here is really about, you know, standards and all around. So on the government side, regulatory oversight, all of that stuff, it is glaring, it is clear. You know, we can't speak to those who have actually done the work, but certainly from the government side of things, we cannot ignore what is obvious.
Absolutely, we cannot ignore what is obvious. There were some writings on the wall that were clearly out there that shouldn't have been ignored. Thank you very much. Engineer Ogundalu, this question is to you. If you had a magic wand, if you could do abracadabra and everything works well, you know, Nigeria becomes the mecca of high-rise buildings, great architectural work. What would you do? What, in your own experience, would you do that could make that difference? Are there any sort of key pointers that you would want to put out there in your experience that could bring us to of high-rise, great high-rise buildings as well?
Thank you very much. The first thing I will mention is that Nigerian engineers are good, they are great, and they have been designing, developing, supervising many high-rise buildings in Nigeria. And they are standing and they are perfect. I could give you an example of the Cocoa House that was done more than 30 or 40 years ago in Ibadan. It's still standing. I can also tell you that I, as a staff of Riverop and Partners, I designed so many high-rise buildings in Lagos. They are still standing. So I believe that we can do that. Now, the problem is, from my experience, when you are designing a structure is supposed to support dead load and live load. Dead load, probably you have, let's say, self-weight of the slab. If you are talking about a 150 slab, you are talking of a self-weight of 3.6, finishes about 1.2, that's 4.8. You multiply with a factor of safety of, say, 1.4, that's the code, and then the live load for residential is 1.5. You multiply with 1.6. So each of those loads have factors of safety. And the materials also have factors of safety. You underrate the strength of the material. You multiply with 0.8 or 0.75 or 0.67, depending on the code you are using. So each of those things have safety factors. As an engineer with AROC, I can tell you I supervised almost all the international contractors that you have in Nigeria. And those buildings are safe and they are sound. Now, when it comes to high-rise buildings, I'm sure that there are Nigerians that will handle this with no problem. Now, coming back to the issue of the collapsed building. One of my colleagues have already mentioned that you have the signpost, there is no name of any company on it. That is not good. Now, you do your design, structural drawings, you hand it over to the, to the agencies. It's stamped. no problem. When it comes to the construction, like I stated in my paper, you must have a resident engineer who is supervising that building right from foundation to completion. And what's the purpose? Is there to check that the contractor fixed the reinforcement as specified on the drawing. Once that is missing, and you cannot guarantee if the reinforcement was properly fixed, your building is not going to be stable. You cannot guarantee the stability of that structure. Now, when we started high-rise buildings, we had all those things in place. There is a design contract, there is a supervision contract, and you go there every time that you are needed. It's either you are there permanently, or when the contractor has fixed his reinforcement and he wants to cast, he calls the company and the company sends a representative, and we go there and we visit it, and immediately you come back to the office, you write a site visit report. Now for the Koi collapse, do we have any site visit report? Do we have any paper by any engineer who satisfied each floor reinforcement till it got to where it is? That building is under dead load. Nobody is living inside it. For that building to come down, total collapse, there are so many things involved. So I don't know if I've answered your questions or not, but there are still more stories that will come out in respect of that. For example, in one of my projects, I was invited to come and look at a job. The cantilever had failed. It was already deflecting. And the client said, Wale, come and help me look at this job. What happened? And as soon as I got there, I said, look, it's either they didn't put reinforcement in this cantilever or it was wrongly placed. And they said it was checked. I said, who checked it? And they pointed to a man. I said, are you an engineer? He said, no. Then what are you? He said, he's an architect. And I told him point blank, I said, you are not qualified to inspect and approve this reinforcement. Oh, he said he was taught in school and he felt he could do it. I said, well, if you approved it, I'm sure they didn't put reinforcement. He said they put it. I said, then they put it wrongly. So when the argument was getting tough, I said, don't worry, we don't need to argue about this. Just get me a worker, let him chisel the top 25 mm over a box. I just drew a box, 300 by 300. I said, chisel it 25 mm. They chisel it 25 mm because the cover is supposed to be 25 mm. They chisel it 25 mm, and there was no reinforcement. I said, go ahead to another 50 mm. They chiseled, there was no reinforcement. I said, so they didn't put it. He said, but he saw it. I said, they put it wrongly. For a cantilever, the reinforcement is supposed to be at the top and then goes over the cantilever and then returns back. But what did they do? They put it on the floor, on the bottom, then they turn it up, and by the time they got to the line of the beam, they stopped it. And even though they put reinforcement, it was wrongly placed, it was not effective, and it's as if you didn't put any iron rod at all.
I see. Thank you very much, Engineer Ogundalo. That was a very relevant case study. I am conscious of time. There are some appointments in the next 3 minutes that some people have messaged saying that they have to run to. Please, if you have any questions, we still would like to solicit your questions. We are on WhatsApp as well. So the Nigerian British Business Forum is on WhatsApp. We're available via email, and our speakers will be available to answer your questions. So please send an email to info@nbbf.co.uk or info@nbigroup.co.uk. If there are any pointers that you would like us to highlight in the communique, which will be going to the federal government as well as the state government, please endeavor to highlight that in there. We'll be gathering the information from our speakers, some of the pointers that they've given, especially around regulations. We'll be putting that together as well as part of our communique. We want to thank you. I personally want to thank all the speakers. I've learned a lot. I don't have the money yet for a high-rise building, but I almost feel like I can go into one right now as a financier because I've already gotten all the must-dos and the do-nots that is needed. If there any way that we would, anyone on the call would like to contact the speakers, please reach out to us as well. They're available for any projects or any consultation work that you might need as well. Ladies and gentlemen, my name is Sean David Onomasi. It's been an absolute pleasure spending this morning / early afternoon with you all. Thank you to all our speakers, and thank you to everyone that has joined. Till the next time, we do wish you a beautiful rest of the day and a beautiful weekend. Thank you very much, everyone. Thank you.
Thank you.
And on that note, Mr. Falabiando, do you have any last minute sort of closing remark, Mr. Falabiando? That's our chairperson of the Nigerian British Business Forum and the global units as well. So Mr. Andrew, do you have any last minute? You're on mute, sir.
You're on mute?
Abi, you're on mute.
Falabi, you're muted?
Yes.
Right.
We can hear you.
It's been a Saturday very, very well spent. Personally, for me, I would say that the investment has been worth it. It really has been worth it. And I just want to once again thank all our speakers. You have been incredibly brilliant. Engineer Dr. Wale Ogundalu.
Yes, sir.
Engineer Kade Ige.
Thank you.
I call her Lady Udo Okonjo.
Thank you.
Architect Olumide Udukale. Engineer Dr. Sulu. He is the chair of the Nigerian Infrastructure Group. Engineer Tomi Adebayo.
You're welcome.
Thank you so much. And for everyone that has been here this afternoon, I believe that you have benefited tremendously. And I really do wish you all well. God bless.
Amen.
Thank you.
Thank you very much.
Thank you, everyone. You have a great evening. We'll rest of the day.
You too.
Very
You too.
Thanks,
You.
everyone.
Thank you.
Thanks for coming.
Thank you.
On this note, we will bring the event to a close. Once again, thank you all.
You're welcome.
Thank you.
Thank you. Bless.
Thank you all. It was a nice one.
Thanks, everyone.
Oh,
From
that was I knew that voice.